Okay, I'm going to go over the key for Quiz 5 for Math 21A, Section D01. The first problem says calculate the derivative with respect to theta of cotangent of theta, and we also define cotangent of theta for you as cosine of theta over sine of theta. Okay, so the first thing to remember is our quotient rule. The quotient rule tells us that the derivative with respect to x of a function f of x over another function g of x is equal to the derivative of the function on top, f prime of x, times the bottom function, g of x, minus f of x times the derivative of the bottom function, g prime of x, all over the bottom function squared, g squared of x. Okay, so now if we apply this to our problem, we know then that the derivative of cotangent of theta is equal to the derivative of the cosine of theta over sine of theta. And now applying our quotient rule, we know then that this is the derivative of the function on top, cosine of theta, which is negative sine theta, times the function on the bottom, which is sine of theta, minus the function on top, which is cosine of theta, times the derivative of the function on the bottom, which is also cosine of theta, all over the all over the function on bottom squared, so sine squared of theta. Now this simplifies to be negative the quantity sine squared of theta plus cosine squared of theta, all over sine squared of theta. Now sine squared of theta plus cosine squared of theta, that's just 1. So we have negative 1 over sine squared theta. Now sine of 1 over sine of theta, that's the cosecant of theta. So we've got negative cosecant squared of theta. And that is our answer. The second problem says, suppose a piston is moving up and down, and its position at time t is s of t is equal to a times the cosine of 2 pi bt. Calculate its velocity, acceleration, and jerk. Okay, so the velocity with respect to time is just the derivative, the first derivative of the position with respect to time. Now if s of t is a cosine times 2 pi bt, then the derivative is, we keep the constant out front, the derivative of cosine is negative sine 2 pi bt, and then we have to multiply by the derivative of the function that's within, which is 2 pi bt. Now 2 pi bt, the 2, the pi, and the b are all constants, so what we've got is a constant times t. The derivative of that is just that constant. So we have a 2 pi b left out here. If I rewrite that a little more simply, I get negative 2 pi b capital A sine of 2 pi bt. Then the acceleration with respect to time, that's just s double prime of t, the second derivative of the position. Now if we take the derivative of the velocity with respect to time, then we're going to get this constant stays out front, negative 2 pi ba. The derivative of sine is cosine of 2 pi bt. And then we have to again take the derivative of the function that's inside, which is 2 pi bt, which adds another 2 pi b out on the outside. So now, if I simplify this a little, I get negative 2 squared pi squared b squared a cosine 2 pi bt. Okay, finally, the jerk with respect to time is the third derivative of the position with respect to time. It's the derivative of acceleration, just like acceleration is the derivative of velocity. We go ahead and just differentiate the acceleration. We're going to get this constant stays out front, negative 2 squared pi squared b squared a. The derivative of cosine is negative sine of 2 pi bt. and then we take the derivative of the function that's inside, which puts another 2 pi b out here. If I simplify, I get negative, the two negative signs cancel, and I get 2 cubed pi cubed b cubed a sine of 2 pi bt. Okay, now the next question asks us, what happens to each of these functions when you double the frequency b? That is, replace b with 2b. Now let's just start with the velocity with respect to time. So v of t is equal to, originally it was negative 2 pi ba sine 2 pi bt, but let's replace b with 2b. Again, replace b with 2b. And if I simplify that, I get negative 2 squared pi ba sine 2 squared pi bt. Okay? Now if we do the same thing for the acceleration, we get negative 2 squared pi squared. Now we replace b with 2b, so I have 2b squared a sine 2 pi 2b t. And if I simplify that, I'm going to get negative 2 to the 4th, because there's a 2 squared that comes out here, pi squared b squared a sine 4 pi bt. And finally, let's do that for the jerk. And we get negative 2 cubed, excuse me, not negative, just 2 cubed pi cubed. We replace b with 2b, so I have 2b cubed a sine of 2 pi times 2bt. I can simplify, and I'm going to get a 2 to the 6th out here because of this 2 to the 3rd, pi cubed b cubed a sine of 2 pi, 4 pi b t. Okay, now if we compare the velocity when we're replacing b with 2b to the velocity when we were just using plain b, you'll notice that the biggest thing that's changed here is there's a factor of 2 here, another factor of 2. So this is twice what it was before. Here there's 2 factors of 2. So this squared went up to the power to the 4th. So this is times 4 of what it was before. And finally the jerk, there's 3 factors of 2. So this was 2 to the 3rd, now it's 2 to the 6th. So this is times 2 to the 3rd, which is 8. So what happens to each of these functions when you double the frequency? The velocity doubles, the acceleration quadruples, and the jerk is 8 times as large.